Hello everyone. It's continuation of our previous video. So we're discussing here the key map. Now our previous video is we're dealing with this 110. So this is in min terms function is x is 1, y is 1, z is 0. So 110. This is 1 0, this output. So this is the term x, y, z bar. So this one, we also explain this one. So next is this output here, 1 0 0. So where is that 1 0 1 0 1 0? Here. So x is 1, y is 0, z is 0, 1 1 1 0 0. Okay? And the last here output is 1 0 1. So this one x is 1, y is 0, and z is 1. So x, y bar, z. Alright, so these are unsimplified function. X bar y z bar plus x y bar z bar plus x y bar z plus x y z bar. This is unsimplified. So nakita nyo, mataas na function yan, no? Mataas na function. So pag in-implement natin, if we're going to implement this function, unsimplified function using logic gates, we have to have several gates to make this function, to implement this function using logic gates. So not only because this logic drawing here is simplified already, so there's only how many gates? 1 2 3 4 5 gates. But this one, you think how many gates this one? If we're going to, okay, I will show you how to, what's the difference if we're not going to simplify the function and implement that function using logic gates. Okay, so like x, we have here the input x, y, z. So x bar, y bar, z bar. So you have to make a NOT gate. Then z bar also NOT gate to have this x bar, z bar, and this is y. And ANDing these three variables, if you have three inputs AND gate, so if limited only to two inputs, so you have to have a two AND gate here to connect these three variables. So you have, they say we limit to just two inputs AND gate, one. So connect one, then the output of this will connect to another gate. That would be, so this is now the x bar, y, z bar. It's only one term. So that's already the number of gates, 1 2 3 4 gates. So for sure this is, well, anyway, we have already inverter here, so we'll not make another inverter here. So the next term is x, y bar, z bar. So just stop here. Use another color. Stop here. And y bar. So by this time you have to make again another NOT gate for the x bar, for the y bar. Okay. Then x, y bar. So this is now your y bar. This is y. Okay. Then the third variable is z bar. So we have already z bar here. So just stop here. Okay, you can connect here. Okay. So adding these three variables, the y bar here. Okay. So this is now your x y bar z bar, and that one x y bar z bar. This is the output x y bar z bar. Then the third term is x y bar z. So here's another color. Say x y bar z. So we have here x top before the inverter. Okay. Then y bar. So we have here, this is y bar, this y bar, this y bar. Then you can add that one so that you will not get lost. So that this is actually x y bar. This is x y bar. Then you have another variable which is z. So z. So here, tap here before the inverter. Then another AND gate. Again, because we limit our AND gate to just 2 inputs. So to connect 3 variables, ANDing 3 variables, we need to have 2 AND gates. So this is now the x y bar z. Okay, this is the third term. The last term, final term, is xyz bar. Is another color. So x y z bar. So where's the x here? This is the x here, from here. So you can tap here, x. Then y is here. You can tap here. So this is xy. Then you have, finally you have z bar. Where is the z bar here? So you can tap this one also, z bar. Just here. Okay. Take note na dyan yan. Okay. The z bar. So you have this output here is x y z bar. So this is a final term. Now, this is not the final output yet, because you have 1, 2, 3 output. We need only 1 output. So 4 output rather here. This one, the blue, the green, and the like purple. Okay. Finally, what will happen to these 4 outputs to make it one function f or output? So you have to OR this one, no? Using this gate, OR gate, 74LS32. So make an OR here, 2 inputs. We limit our input to 2. Okay, and this one, and this is now the output of this is x bar y z bar plus, because this is an OR gate, plus this one is x y bar z bar. Okay, the output of this gate here. Now about these two, the x y bar z and x y z bar, so you have also another OR gate here. Connect, and this finally, this is x y bar z plus x y z bar. Then finally another OR gate, lagay na natin dito, just put in here. Finally, this is our function f. Okay, so compare this combination of gates than this one, same output guys, same output, only 1 2 3 4 5 gates, and this one, how many gates we use? We limit only to 2 inputs gate, 1 2 3 4 5 6 7 8 9 10 11 12 13 gates. This one is only 5 gates, this one is 13 gates, same output guys, f. This is the output. Okay, so this is how to simplify. That's why we need to simplify to avoid, having too much number of gates in one circuit in your design. Saving time and money, of course. Okay, so actually this one, aside from this key mapping technique, we can also simplify this using, it's like ordinary like mathematics or algebra, by collecting similar terms. Like this one, what are the similar terms for this function? That by the way, we have the also Boolean laws, or Boolean Boolean laws, that there are some terms that you can simplify, and will have a corresponding of only one variable or one. So like for example here, what is the common term? Like for example this one, if you pair this one, what variable we can cancel here? So x bar y z bar, x y z bar. So what are those common? Their common is the z bar. The common is z bar.